Now we're recording everywhere, that's good. So today we're moving on to, we're in our 8th week now, I guess. Last week we learned about how to ask the user for inputs. This week we're going to learn how to use logical function and selection structures and start to build programs that are able to choose. They're able to use logic to do things. This becomes quite useful. This is really what computers are all about, is doing some logical problems of some kind. So hopefully this will be interesting for you. Let's get into MATLAB. Where's my MATLAB? Okay, so one of the things we should probably look at before we get too far into things is let's see, should probably get into the idea, talk about doing some pseudo programming really quick. Before too long here, our programs are going to get complicated enough that we're going to want to do them on paper a little bit before we do anything on the computer. So I'm going to go to Blackboard, MPCC Blackboard. We'll log in here. To our programming class. Now I'm going to open up our assignment for this week, even though you guys can't see it yet. I started it up last night. That's the wrong one. And the first question after your place where you are going to submit your file for lecture is going to be a file called, we're going to have this file that you're going to download called flowcharting.doc. And if you've never done a flowchart, then this will be a little bit of an adventure for you. But a flowchart is essentially a way to organize some tasks or ideas into a structure that flows and allows other things to flow through it, for example, data. And this lesson is it's a lesson I found that I kind of like on flowcharting. And they give you some definitions and some ideas, and then they take you to the actual flowcharting. And flowcharting uses symbols and some graphical organization. And some of the symbols are this rectangle that has kind of the rounded edges, this rectangle that has the sharp edges, the sharp corners, then this little parallelogram, and the diamond, and the circle, and this, they call this magnetic tape, but this is essentially like a storage thing. It's a little, looks like a little call-out box, but it's a little oval circle with this little tail on it, I guess. Then you have this other magnetic disc thing they call it, is this three-dimensional cylinder thing. And then there's this funny looking banner, and then arrows, and there's dotted lines, and there's displays, all kinds of symbols, and there are more than that even. But the whole idea of the flowchart is to have these symbols representing different things in a flow of ideas, a flow of data, a flow of a process of some kind, and to let that let those symbols represent what you're trying to accomplish. And before I even get on too much further, I just wanted to explain what you're going to be doing in this document. You're going to fill in all the blanks in all the questions that they ask. In this first one, they have these in-text questions, one, and then they have questions later on that they ask, and then they actually have to do some flow charting later on. And so everything that is required to be filled in this document, you're going to fill in, and then you're going to return the document to me in this problem in the homework. But here's where we really want to be, is to the examples of flowcharting. So here is an example of a flowchart that finds the sum of the first 50 natural numbers. So this is how you begin. You have this starting symbol that is on this rectangle with the rounded corners, and that's where you begin the entire process. And the first thing is you're going to have this thing we're going to call sum, a variable or some kind of a object that you're going to call sum, and you're going to let it equal 0. And it's important to start off programming and flowcharts by defining things and giving them an initial value. So that's the initial value of the sum is 0, and we're also letting the initial value of n equals 0. So we have these two things, two variables, one's called sum, one's called n. Well, then we go to the next step here. So this is, you just follow the arrows down. The next step redefines n as the number n, which is 0, plus 1. So now n has been redefined as 0 plus 1, which is 1. So n is now 1 at this point. And you could even put a little notation over here that's the little dotted lines with a little box out here. It says, for the first time through, n went from 0 to 1, right? And for the second time through, n will go from 1 to 2, for example. And you could make a notation if you wanted to, just like you make notations in MATLAB with the little percent signs. So you have n equals n plus 1 as your, and we usually call this an advance. So you're advancing the index. The index number is n, and you're advancing the index by 1 here. And then the next thing here is to take the sum, which is 0, and let it equal itself plus n. So n is now 1, and if sum is 0, then sum is now going to be 0 plus 1, which is 1. And then you ask yourself the question, is n equal to 50? Have we done this 50 times, in other words? And if it's no, then you go out this way, and you put this is the no path. If it's no, you follow this path around, and you start in this loop again, where you let n equal n plus 1. Well, our n is now equal to 1, because we didn't go back here and redefine it as 0. Our n is equal to 1, and when we go to this step, n equals 2 when we add to it. And you go through here and you add 1 to the sum again, and that sum is now 1, and so you add 1 to it, you get 2. And is n equal 50? No, it's not. And then you go back around and you keep doing this until you've done it 50 times, till n is equal to 50, and you find out what the sum is. And then when n is equal to 50, that means you've done it 50 times, and you print the sum. In other words, the sum is printed out to the screen or onto a piece of paper or whatever else, and you're done with your program. The logic part of this is this question right here. Is n equal to 50? You're asking a question that has two answers, no or yes. That's what logic is all about, and that's what we're going to be learning about how to make MATLAB do today. This idea of making this thing go around and around and around and around, we will touch on that a little bit today, but we will do more of that in the next section or next week's work. So that is a very simple flowchart of a program or a function or a whatever, a machine, a process that will add up the first 50 natural numbers. Here's another example. Find the largest of the three numbers A, B, and C. So we start off and we're going to read three numbers, A, B, and C. Maybe those numbers are inputted by the user. Maybe those numbers are given to us by the computer. Who knows? Maybe they're pieces of data that are read into the computer somehow. But we're starting off by reading A, B, and C. That's the first thing we do. The second thing we're going to do is we're going to ask, is A greater than B? First question. If it is not, then we ask, is B greater than C? If it is, then we print then we print B down here. However, if we go here and A is greater than B, yes, then we go this way, right? But notice that this no one has two paths to it. So if we have no, we go this way and this way. We do two things. We print C, right? If we do this, essentially what we do is in the end, we get, we're comparing A and B, and then B and C, and then A and C, right? And anytime we find one that is greater, we're going to print it out, and in the end, we're going to get the biggest one here. We want to find the largest one, and it all actually has to do with this logic. And this is a little bit more complicated. We have these four logic questions here, or these three logic questions. How are these three logic questions going to get us to the end? Well, let's try to figure it out. It's always a little bit tricky, but let's figure it out. So we go from if A greater than B. If A is greater than B, then we compare it with C to see if it's greater than C. If A is greater than C, then A is the biggest number because we compared it with A and C, and it gets printed. So that's one path. If A is the biggest number, it will go from here to here to here, and it will get printed. If A is not the biggest number, but it's bigger than B, then it will go from here, and it is bigger than B, and then here it is not bigger than C, and so C will get printed. Okay? If A is not the biggest number, but it is bigger than B, then C has to be the biggest number, and so C gets chosen. And so if that wasn't obvious from the beginning, hopefully it is now. Then if A is not the biggest number, in fact, if A is the smallest number, then if A is bigger than B will be answered no, and you'll go this way. And then it will ask, is B greater than C? Well, if B is greater than C, then you print B because it is the biggest, right? But A is the smallest, so it never got printed, and you would print C in that case, here. Let's go through here so that was for A. We did A is the biggest, let's do B is the biggest. If B is the biggest number, we'll ask this question, is A bigger than B? And A will not be bigger than B, so we will go this way and this way. And we ask if B is bigger than C, and if B is bigger than C, which it is, then we go ahead and print B, and B is the answer here. Essentially, you have two paths for each question that you ask, and well, you only have two paths for the first question, but you have two paths for this question here and this question here, and in the end, it will all result in printing the one that ends up being the greatest. If C is the greatest, this one, and you ask this one, it turns out, well, whether or not it's correct, you're going to print C because this question will give you the correct answer and print C. So this answer will answer no, and we'll print C here. So anyway, the point is, no matter what you do, you're going to get out here. The one that gets printed last here is going to be the biggest number, and that's what you want to do in this particular program. So logic can be very difficult to work out unless you can map it out on paper. Now, is this the easiest way to do this program? Maybe not. There may be many different ways to put together this program, put together this flow chart, and write this program. In fact, that's what programmers do, is they spend a lot of time trying to map out different ways to solve different problems so they can make different programs to solve them different ways. And in the end, you're looking for the program that does it the best, the most reliably, and the fastest. So flowcharting can be an extremely useful tool in that process. Sorry, my throat is really dry, so I'll be drinking a lot of water today. Here's another one where we're taking the factorial, which is the factorial of some number n, which essentially you take all the numbers, all the whole numbers less than n all the way down to 1 and multiply them together, and n itself. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And here you can see there's another loop in here, and there's also going to be some definitions where we're going to read some letter n. Somebody puts in some number for n, maybe put in the number 15, and we're going to start with two numbers, m equals 1 and f equals 1. And we're going to say f is equal to f times m. Excuse me. Why do we want to do that? Well, essentially we're taking two numbers and multiplying them together, right? You have two numbers, 1 times 1 to start off with, but what we really want to do is 1 times 2 times 3 times 4 times 5. And that's okay, we'll get to that. The f is equal to the factorial. The m is essentially our index, the thing that's going to increase every time. And so we ask if m is equal to n. If m is equal to the biggest number, which we're trying to multiply by, then we're done. If it's not, then we add 1 to it and we multiply it in again. And then if it's not, we do that again and we keep adding together. So the first time we get 1 times 1. The second time we get 1 times 2. The third time we get 1 times 2 times 3. That's next time we get 1 times 2 times 3 times 4. And we do that all the way up to the number n, which would be the factorial. And when we get to that far, then we print off that number f for the factorial, and you calculated the factorial for f. And again, is that the easiest, simplest, fastest way to do it? Maybe not. There may be other ways to do that as well, and that's the whole point of flowcharting. So in this particular part, they actually give you an example to do. The company's salesmen are selling toothpaste and tooth powder. The company has 50 salesmen, and they give 10% commission on the sale of toothpaste and 20% on the sale of tooth powder. We want to draw a flowchart to compute and print the total sale and total commission for each salesman. And here is a blank flowchart for that. They go through and they talk about they go ahead and throw together this flowchart of these different symbols, and then they throw in the different you are supposed to throw in the different values in here. So you've got S for salesman number, P1 is the amount of sale of paste, P2 is the amount of sale of powder, K is the counter for the number of salesmen, and so on and so forth. So you're going to try to build a flow chart for that. And then they have another one here. We're modifying it for total sale and commission, and so we're writing the values of the variables for 50 salesmen. So if you have 50 salesmen, what would the flow chart end up giving? How many numbers would you give you? And that means that you're going to have a number of salesmen S equal 50. So I'm going to leave that for you guys to figure out. It's something you have to kind of think about to do. And I think that's all there is to it there at that point. There are a few more questions down there, but you're done at that point. So that's the first part of the homework this week, and I wanted to show that to you. In other parts of the homework, you're going to have some files that you have to link. You have to put into your programs. And so what you want to do with these is you want to download them into your workspace. So you can go ahead and click on them and then save the file. And then once you've saved the file, come up here and open it up in MATLAB. You can go to MATLAB itself and open it. Now that I've downloaded it, I can go to MATLAB here, and I can open in my downloads, go to downloads, it's called Hot Tub, isn't it? hottub.dat. I forgot that the .dat is not what they want anymore. They want .mat, but I'll change that. But then you can just open it in MATLAB. It'll open it and you can add it to your current directory, and then you can use it in your programs. So those are a couple of different things that are a little different in this week's assignment for you. All right, so let's get started on the material that we're going to be using today, the functions and the different things that we're going to learn about today. So First of all, logic. Logic is all about asking yes or no questions and getting yes or no answers. So what are the different kinds of things that you can do in MATLAB with logic? We could always do help logic and find out. Right? So it's not in there, but we can search the documentation and see what they've got here. Here we learned something about logic. In MATLAB, the logical operator, the logical answer for things are 0 and 1. 0 is false, and 1 is true. So that's important to know. You need to know that. Let's see what else here we have. That's okay. They don't have a great... No, they don't have a great thing on that apparently, but that's okay. We'll go ahead and do it ourselves. So the logical operators in MATLAB, what are they? And they may actually call them relational. Let's try that. Help relational. There we go. There's the section on relational operators here. So here are the relational operators. You have the less than and the greater than symbol. So is A less than B, B less than A, right? You have, or B, A greater than B, A less than B. Then you have the less than or equal to, or the greater than or equal to signs. And then you have the equal to sign. You use a double equals for that. This right here, this line is asking, is A equal to B? Exactly equal. And then you have the about equal to. So, well, yeah. So the about equal to has this little sigil, they call it, and then the equal sign. And that tells you if they're close to each other in size. I don't know how close it says because I've never really used it. So anyway, those are the numerical relational operators for comparing numbers and arrays. You can actually compare strings as well. Let's see if one string is equal to the other string. However, I don't think you can compare them if they're greater than or less than. But you can do entire arrays and say, well, how do you do entire arrays? Well, we'll get to that. We'll figure that out. So let's try out some really simple stuff. Let's do this. Let's do 5 less than 4. Oops. 5 less than 4. Let's see if MATLAB knows how to do that. It does know how to do that. It says that the answer is 0, which means that it's false. 5 is not less than 4. 78 greater than 34. The answer is yes, it's 1. So that's true. 78 is greater than 34. And this can even do imaginary numbers. So if I do 78 plus 6i, for example, and I do less than 45 minus 8i, it says the answer is 0. It is not less than that. So it's got some serious abilities. You can also do it with variables. So if I say that x is equal to 4 and y is equal to 5, and I say x greater than y here, the answer is 0. So it's false. X is not greater than y. I can also have a z equal to 5, and I can say is y less than or equal to now z And it turns out the answer is yes, they are equal to each other. But if I ask, is y less than z, it says it's false because it's not less than, it is equal only. Let's see, anything else we need to talk about with the relations? No. And that's fine. Let's do something else. There we go. I put in logic and not logical. So we do have a link to logical operators. And let's see, short circuit, not what we want. So logical operators, we have the AND operator, A and D, but you can also use the shorthand AND symbol. We have the NOT operator. Oh, and that's what the little sigillia meant when with the equal sign. I was a little confused by that. That's not equal to, not about equal to. I'd forgotten that, so this is good to know. So you can use either the sigillia or you can use NOT, the NOT operator. We have the OR operator. So the OR, you can either use OR or you can use the straight up and down line. We have the logical exclusive, XOR, it's often called, right? We have all, we have any, we have false, we have find. There are quite a few other ones. We're only going to use really these top four for the most part. And we'll actually use the top, the top four here. We won't use the other ones for now. So we have these operators, and let's go learn how to use these really quick. Oh wait, I didn't use the relationship. Let's do the relational operators again with arrays. I didn't do an array yet. So let's define an array. A equals some array of numbers, whatever it is. Let's do 1, 2, 3, 4, 5. That's fine. And let's have another array. B equals -2, 0, 2, 4, 6, or something like this. So we've got two arrays here, and what happens if I do let's do x less than y. Let's ask the question, is x less than y? What do we get? Well, oops, not x less than y, a less than b. There we go. So here's the answer for asking the question, is a less than b when they're arrays? It gives you an array of answers. So is 1 less than -2? No, it's not. So that gives us a no. Is 2 less than 0? No, it's not. Is 3 less than 2? No, it's not. Is 4 less than 4? No, it's not. Is 5 less than 6? Yes, it is. So we have one example, one place here where the elements of each of these arrays that correspond with each other, in other words, in this case, the fifth element of the first and the fifth element of the second array, they answer this condition correctly or truly. So you get a 1 here for true, and then all the rest are false. So you can do that with arrays. You can use these things with arrays. And then the not equal to sign, we could do where's my, there it is. Not equal to b, right? You say, when is A not equal to B? Well, it's not equal to B in every place except right here where 4 is equal to 4. So 4 equals 4. So anyway, that is using the relational operators with numbers and with arrays. Now, let's look at another question. Let's do A greater than no, well, we need another one. Let's make another array. Z equals, there you go. Let's make it all the same number. All just 8s here. So we have A is this one, we have B is this one, and we have C is this one, right? Those are our 3 different arrays. And I'm going to ask this question. Is C greater than A? But I also want to ask the question at the same time, and is C greater than B? So the question that I'm actually asking here is when is C greater than A and C greater than B? Which numbers in C are greater than A and B, in other words? So let's find out. Well, C is greater than A and B in every single spot, because C is full of 8s, and the biggest number in A and B is 6. So we get trues all the way across the board. All the elements of C, every one of these 8s is greater than the elements in the other two, the corresponding elements in the other 2 arrays. What if I did this one? What if I did a very similar one to this one? C, instead of C greater than A and C greater than B. What if I did C greater than A? No, let's do it differently. Let's do A greater than B and A greater than C. But let's, instead of doing an and, let's do an or. So you do this one. Sorry, you do this one. So in this question, I'm asking where is A greater than B or A greater than C? So I look at A and I say, when is this one greater than either this one or this one? The answer should be never, because it's never, well, no, it should not be never. So A1 is always greater than -2, but not greater than 8. So it is greater than this one, but not this one. But this says or. So that satisfies the first one, so that's okay. A is greater than B. But is A greater than B here? Yes, it is, but it's not greater here, but that's okay, because it just says when is one of them correct, one or the other. A is greater than this one, not greater than 4 is greater than this one, but in this one it's not. So we should have 1s everywhere except the last 2, I think. So let's take a look. Looks like it, yep. It's in the first one, A is greater than B. In the second one, A is greater than B. In the third one, A is greater than B. But in the last one, it's not greater than B, but it's also not greater than C, so that's false. It's not greater than B or C in the last one, so it's false. So that is the OR operator. Now with these two things, you can also use the AND. Let's figure out how to do that. Can we just put in AND? Looks like not, right? So we have to figure out how to use AND. So let's go ahead and let's do the help AND. So the logical AND. So it looks like we have to have AND with parentheses and some stuff inside of here, right? Let's actually look at our document page, see if we can see some examples of this being used. So we have a matrix A and we have a matrix B. Then we can use A and B right here. They're doing A and B. I want to see him do this is actually doing something that I don't really want to mess with at the moment. We'll work on stuff like they're doing there towards the end of the class. Don't want to do it here. Okay, so let's try this. Let's try this really quick because I think we can do this. Let's do the AND operator. We'll have the AND out front and we'll do our parentheses. Let's see if this works this way, and if it doesn't, we'll just not use it. So we'll see if this works. It does. So the AND operator can be used just by putting AND and then the two statements inside of it. And do the same thing with the OR operator. If we use the OR operator instead of the bar, then you just put these two things in parentheses with a comma in between them, take out that OR operator, and it gives you the same answer. So you can do that as well. So the NOT operator, you can ask, you can do the NOT operator is, let's go up here to this one, oops. Use the NOT operator in here, which is this guy here, right there. Maybe not. Oh, can't use it in that case, but we could use the exclusive OR. So this is exclusive OR. If I'm using this property, we'll get what we want. So in this case, we want to know if one or the other is true, but only one or the other, not both. So it's in this case up here when we use the OR, it could be both. Something could be greater than both of them. It gives us the same answer for these things because it's always exclusive. We're looking for when A is greater than B or A is greater than C. In this case, it's never greater than both of them. So it doesn't really matter, but that's how you use that one as well. You use it in parentheses with your two statements or your two variables. However you can do that. So these are the logical and relational operators thus far. And what we would like to do is we would like to make some functions that use these logical operators, do a little bit of work with these things. So here's an example. Let's do something related to picking a group. For example, if you're at Disneyland, let's say we're at Disneyland and they have that little guy with the height at every ride, tells you how tall you have to be to get on that ride. Then we can actually build a program that kind of does this. If we have a group of people different heights, let's just make some random heights up here. Say 63, 67, 65, 72, 69, 78, and 75. So we've got just some random heights. These are heights in inches, where 72 inches is 6 feet tall. So we have one 66-foot tall person here, for example. So you got this different group of people of different heights in here. And we've defined that in this little array here, height. And we want to know which ones of these people are greater than a certain height. Let's say greater than 5'6" or something like this. So what we want to do is we want to, let's make another thing called ride. The people who can ride this ride are the people that we find in height Ch.8 who are greater or equal to 66 inches. That's 5 feet 5 inches. So the find function, I can't remember if we've used the find function before, but the find function will look in an array for something that's using this these operators that we've talked about, this comparison operator. So it's going to find everything in height that is greater than 66. And how is it going to return that for us? Let's find out. Ride gives us this array. We've got an array now of 1, 2, 3, 4, 5, and there's 1, 2, 3, 4, 5, 6, 7 numbers in here. So what did it give it? What did it give to us? Well, let's take a look. The first one did not meet the requirements. It's not bigger than or equal to 66. So that is the first index in the array, or the first member of the array. And notice that 1 is not here. 2 is here. 67 is bigger than 66, and so it shows the index 2 for the second one in the array. Satisfied this condition. Third one is 65. It does not satisfy our condition, so 3 doesn't show up here. Fourth one is 72. It does satisfy it, so it shows up. The fifth one and the sixth one and the seventh one all satisfy our condition of being at least 66 inches tall, so they all show up. We get 2, 4, 5, 6, and 7 in a new array. What do we do with these numbers? Well, we can use these numbers now to pull out those different heights. Say, what are the heights of the people that are whatever. So we can say, for example, let's take height, put in some parentheses here, and I find out height 2. What is height 2? Well, height 2 is 67. It's pretty easy to do it when you have a small array like this, but if you had thousands and thousands of people and their heights in a file, this would be a very useful feature to be able to search them by height and figure out who are taller than a certain number of inches, and then put together you can put together an array of people that win, an array of people that can ride the ride, right? So what if we wanted to print this out? Well, we know how to do that from our last let's actually make an M file here. From our last class, we learned how to print things out to the screen, so we can do this. Let's do display. We'll make this nice and professional. The following people can ride the ride. Well, maybe we'll call it Space Mountain, right? The following people can ride Space Mountain. Everybody's got a number in their hand so they know who they are. And then we can go printf. There, this is the function print. So we can print things. So essentially, this allows us to print things from an array, and we're going to print off the following things in the array. First of all, we're going to start off by printing off let's say visitor number. Okay, so in the place of we're gonna say visitor number, and let's do we're going to put in a number from our array there. So we're going to put in a number that is 0 decimal places. If you remember how this goes from the last video. If not, you can watch it again, I suppose. So go to a new line here. And then we're going to use a new function here we call accept. No, actually, no, we're not going to. We're going to actually so for these two things that we put in here, we put in the visitor number here and the height here, and where these %4fs are. So we're putting in two things here, and that's what we got. We've got to tell MATLAB what we're going to put in those two things. So the first thing we're going to put in is the people who are going to ride. So it's going to be the ride, so person 2, for example, is going to go in. And I want to, I didn't mean to do that. I meant to do this because I want it to be, close that quote there. Sorry. So we're going to put in the person that's going to ride, but then in another column, we're going to put in their height as well, because that's where we say how many inches tall they are. So we go ahead and put in their height, and so we're going to put in the height of each one of these people, but we're going to put the height in of the person that's going to ride. So we put in back in ride. Now, if you're not sure what this is going to do, well, I'm not either, since I'm not sure that I've even coded this right. But let's find out if it does what I want it to do. We'll save it. Just save it as untitled here. And then we'll run it and see what happens. String is not terminated properly. Visitor. Let's see. Line 1, column 6. Oh, there we go. It's right here. Didn't finish that off. Okay, so that's better. Let's try that again. Save and run and see what happens. Line 2. Let's see. F, oh, it's F print F I want to put in there. I just didn't do that right, okay. Little typos everywhere, run this in. Okay, so now this is what it does for us. The following people can ride Space Mountain. Visitor number 2 is 67 inches tall. Visitor number 4 is 72 inches tall. Visitor number 5 is 69 inches tall. Visitor number 6 is 78 inches tall. Visitor number 7 is 75 inches tall. Now we could actually write, we could also do another thing here. We could copy these two lines and do them again, which is a quick way to do this. We could have a little fun with the people. Okay, the follow people must ride the teacups, right? And in that case, we're not going to put in the people. We're not going to put in the people that are going to ride. We're going to have to put in the people that cannot ride. So we're going to have to make a new. We have to do a new thing here. We'll call it not ride. People who cannot ride are going to equal. You remember how we did this up here? The people who ride, we find the people whose height is greater than or equal to 66. So in this case, we're going to find the people whose height is less than 66, right? And so we'll put that in as our not ride. And then instead of using ride here, we'll use not ride. And instead of using ride here, we'll use not ride. Right? We go ahead and hit save and run again and see how it works out. Following plus people must ride the teacups. Visitor 1 is 63 inches tall. Visitor number 3 is 65 inches tall. And of course, with 7 people on our list, it's not a big deal. But if you had 700 people on your list, this would be a huge time saver. We would have been able to sort out all these people within just a matter of a few minutes. And if the program was already written, you could do it, in a matter of seconds or less. So it's a very useful thing to be able to ask these yes or no questions. Is this greater than this? Or is this, or whatever. All these different comparative relation and logical functions, very useful. Okay. Well, let's make something a little bit more complicated. We've got our height vector here. Let's edit this. Let's edit our height vector. And let's put some ages in here. Let's put in some ages. Let's put in an 18-year-old, not a 180-year-old, an 18-year-old, maybe a 19-year-old, maybe another 18-year-old, maybe let's put in a 20-year-old, maybe even a 36-year-old or a 34-year-old or a 12-year-old. So now we've got that. We'll go ahead and close that out. And now height, we're going to call height age. For height and age. Okay, so we've just edited it a little bit. Heightage. Well, this could be useful. Because now we could actually sort people out by height and age, or height or age. So you either have to be a certain height or a certain age, for example. How would we do that? Well, we could do, let's say that people can ride, right? Ride is going to be equal to now find. We're going to find everything in height age. That is height age let's see here. Let's see our first row. So this is we're actually going to be going back a few chapters now, almost to the very beginning, and you might have to review former videos or review some of the stuff in the beginnings of our different books that I've given you. But if you want to look at something that is just in the first row, or just in the second row, or so on and so forth, then you use a very specific syntax for that, and that is the colon here. If you put down a colon, then you're asking for everything in row 1 here. If I do it like this, so this is row 1. So everything in height age, row 1. I want to look for everything in there that is greater than, let's see, greater than or equal to 66, for example. But then maybe I want also, well no, we wanted to do an or, right? So we'll do or, height, age. Now I want to look in the second row. So I do this, comma 2, right? In the second row, to be greater than or equal to, let's say, 18. Now let's make it more difficult for them to get on this right. Make it greater than or equal to 20. Right? So now inside of my find function, I've got two statements, two logic statements, from two different parts, from two different rows of height age. Hopefully I put that in correctly. Let's find out. Let's see. Apparently I didn't do that correct. So apparently my matrix dimensions don't agree, and I don't know why. Let's take a look here. Height age row 1, 2 should be correct. Oh, this is the problem. This needs to be closed here. There we go. So I just didn't close my parentheses after the height age. To choose the second row, you have to close those parentheses off. Now it's not correct either because I've got too many parentheses at the end. There we go. So it's only going to let the first person ride, it turns out. Let's see if that's correct in height age. We'll open up height age. The only person in here, let's see. It's looking for everybody that is greater than or equal to 20 and greater than or equal to 66. That's not right. What did I do wrong here? I did something goofy. Oh, that's because I did this wrong. I actually did the first column, not the first row. I want the first row, so we'll do 1, comma, this. So for rows, you do it this way. For columns, you do it the other way. I think. Let's check that. I'm pretty sure that's correct. There we go. Okay, so now we've found everybody that is, let's see, right, find height age, greater, that's taller than 66 or taller or over 20. So our first person is taller than 66, but he's not over 20, but that's okay because it's either one or the other. And the second one, sorry, that's our second one. Our third one doesn't, our first one doesn't, so they don't show up. Our fourth one does. He's taller than 66 and he's greater than or equal to 20 years old. Then our fifth one also is both. Our sixth one is both. And our last one is the tallest of the group and also the youngest of the group. So he satisfies the height requirement but not the age requirement. So this one lets all these people ride even though one of them is really quite young. Right? And another one is, well, we don't have anybody that's too short, but who's old enough. But anyway, the point is that you can do it this way, and that's nice. You could also do between certain ages. Let's say we just want to do between the ages of, let's go between the ages of 18 and 19, for example. So we'd use a very similar thing here. So we find height age in the first column, in the first row. Let's do everybody who's greater than 66 inches tall, but also that their age is greater than 18, greater than or equal to 18. And then let's do height, age, 2, comma. So height 8. These are the entries in the second row. Second row, all columns. So that's what the colon means. If I didn't explain that, this is second row, all columns. And if you put the colon in the first one, it's all rows, whatever column. Right? So we're looking for height, age in the second row, all columns, to be also greater than, no, less than or equal to 20. Right? So let's hit that and see what happens. So only 2 people meet that criteria. 2 people that are greater than, they're older than 66, and also between the ages of 8 and 20 are number 2 and number 4. So you can really start to sort things out that way. And then, of course, you can print things off if you wanted to. You could print off using this very similar kind of thing. You could say the following people are, above 5'6" and also between the ages of 18 and 20, and then print off these 2 parts of the age, height, or the height, age matrix, the height, age. In fact, I'll do it right here. So the following people are taller than 5'6" and 6 inches and are between the ages of 18 and 20. And then on our next line here, we could just change this to height, age. Right? And we could call this ride, height, age, ride. Let's see. So in this one we have two rows and 7 columns, and so we're using the ride for the ones who are we were using this for their height. So that was the first row, and so we want to use the first row, and the column will be whichever one this one is. So we do 1 comma ride there. We're going to change that when we hit enter here. Say visitor 2 can ride and so is 67 inches tall. Visitor 4 can ride and is 72 inches tall. However, if we wanted to include their age in that as well, we could do that with the fprintf. So the following people are taller than 5'6" inches or between the ages of 18 and 20. And then in this fprintf on the second line, we would do visitor number whatever is this inches tall. Then at the end of this, before we go to the new line, we say and they are, or just say and we put in our number, %4, 0 decimal places, printf years old, just like that. And then we'd have to add one more thing in. We put in the first number ride, we put in height, age, ride 1, and then we put in another thing, which would be the height, age, and we're going to put in the second row and all the columns there. Let's see here, what did I do? Doesn't like that, let's fix that. For F ride. Oh yeah, here we go. I put a comma when I should have put a semicolon. So here I put a comma. I should have put a semicolon because this is actually an array of numbers that we're plugging into here. 1, 2, and 3. I have to have 1, 2, and 3, and that has to be in different rows so we're concatenating correctly. And then it says here, visitor number 2 is 67 inches tall and 19 years old. Visitor number 4 is 72 inches tall and 20 years old. And there you go. So we're using logical functions to answer questions at this point, which is a great function for a computer to do. Okay, let's see here. What do we want to do next? Let's use the find function now to pull out more than one thing out of an array of numbers. Let's see. So let's do temperatures. So in this particular example, we're going to have a building where they're measuring the temperature on each floor, and there are 3 different floors. And each column of temperatures in this array is going to represent a different floor. So the first set of measurements, the first we're going to have 90. We'll start with like 95.3 maybe, and maybe throw in a 100.2. You know, throw in a 98.6. And so those are the first floor, second floor, and third floor temperatures on some day. And then on another day, so we do the same. We're going to do the same thing on another day. So we're going to add. Oops. There we go. We're going to do the same thing on another day. Measure the temperatures again, and we get 97.4, and we get 99.2, and we get 98.9. It's a hot building. Right? And then we do another one. We put another row in here. We do 100.1. We do 99.3, and we do, let's say, 97. Right? So there's all the temperatures we've got, and then now each one of these columns represents a station, or not a station, but a floor in the building, right? So we've got different floors in the building. Each row represents a different day that we're measuring the temperature. Now, what happens if we do something like this? Use the find function inside of our array temperature to find the temperatures that are, say, greater than body temperature. Body temperature is 98.6, right? So everything that's greater than body temperature gives us this array of numbers: 3, 4, 5, 6, 8. What does that mean? 3, 4, 5, 6, 8. 3, 4, 5, 6, 8. Well, if we look at this really quick, 1, 2, 3, that one's greater than 98. 4 is greater than 98. 5 is greater than 98.6. This one's greater than 98.6. That's 6. 7 is not greater than 98.6, and it's also not in our array. Then 8 is, but 9 is not. 1, 2, 3, 4, 5, 6, 8. So what it did is it treated this array of rows and columns like just a single row or a single column, where it counted this one is 1, this one is 2, this one 3, 4, 5, 6, 7, 8, 9. And it gave us the numbers that were greater than 98.6. Now that might be useful, but it might be more useful to know which row and which column something is in. Because then we could actually know which floor we were on, which floor and which day it was greater than room temperature in this building. So what we need to do there is we need to give MATLAB a place to put two numbers. When we just asked it to find numbers, we didn't give it a place to put two numbers. We just said find it. And in this case, what we want to do is we want to create an array. We'll call, for the rows, remember the rows are the days, and then the columns are the floors, so row and column, we'll call day and floor, equal. So now I've given it two variables in an array to put these numbers into, and I want to know day and floor, which ones of these now are going to be equal. So I go ahead and use the find again. And I find temp greater than 98.6. So now it's giving me two arrays. 3, 1, 2, 3, 2, 3, 1, 2, 3, 2, and 1, 2, 2, 1, 2, 2, 2, 3. So essentially the one is, I've got 3, 1, right? So what does that mean? Let's look at 3, 1. Row 3, column 1. Does that work? That's greater than that, right? So it's day 3, column 1. And then day 4, no, that's not right. Day 1, floor 2. Let's see if that one works. Let's see if we're right. Day 1, floor 2. There you go. So day 1 is this first row, floor 2. It is also greater than that. So it's actually made an array of all of the things, of all the days and all the floors that are greater than body temperature, the floor and the day. So that, again, can be quite useful. And then you could actually put together, you could print this out again. There's a way to print this out. Since we have the floor and the day, we could say f print f. And we could say, oops, floor, and the floor that we're interested in is going to be in the floor file, and we're going to use 3.0f at day. Let's see, is that, no, yeah, on day percent was at so we've set this up with 3 different things we're going to enter in here, right here, right here, and right here. And let's see here, how do we want to set this up here? We'll set this up with an array of 3 numbers. And the first one we want it to be floor. We're going to use floor. And we're going to use day. And we're going to use temp. And we're going to use we actually want to use this number right here, answer, so we'll use those answers from before. So floor 1 on day 2 at a temperature of, it didn't give me my temperature because that answer is not correct apparently. Let's try it again here. There we go. So I'm going to take the temperature from that thing. Hopefully that'll give it to us. Floor 1 on day 2 at a temperature of, it's not giving it to me. Where's my temperature? Temp. It should do it. And we should probably do a new line after each one too. Let's do this really quick. I think I'm going to have to make a, there we go. Just couldn't see it. And actually we have some kind of a mistake in here to fix, because it gives us the first 2 correct and then it's got some mistakes in here. It's got quite a few mistakes. So we've got it close, we've just got to fix something in here that's not working properly. That's okay. I'm going to take a little bit of break here. I'm getting kind of dry and I need to take a little break to stand up, walk around, and get a drink of water some more, get some more water. But we will come back here in, let's see, we're supposed to go to 2:30, so we'll come back here in about 7 minutes and we'll troubleshoot this one here and try to figure out what we did goofy, and then we'll move on to some other logic structures that we can use. We got to move on to. All right, so we'll be back soon. Okay, I'm back now. Are you back there in Luke County? Okay, I can see you now. Okay, let's see. So this gives us an opportunity to do a little bit of troubleshooting. Whenever you start writing longer scripts of code here, things that are a little more complicated, you always have some goofy thing that goes on, and this is the goofy thing that's going on here. I should have these numbers that are corresponding with my chart. I only had 3 days and 3 different floors, but I've got 100, day 100 in this chart here. That's not right, and I have a floor 97 here, which is obviously not right. So one of the things that you have at your disposal when you're trying to figure out what's going on with your program, or debugging your program as it is called, is to actually look at the variables. So here I've got this variable floor, which is just a 5x1 double. It only has 5 elements on it, and none of them are 97, 99. And so obviously there's something going on there. These numbers are not coming from here. And in day, they open up day. I don't have those numbers here. The only place that those come in are in the temperature. So apparently I did something funky with the temperature, because I'm pulling in numbers like 99 and 100 when I shouldn't have. And so I need to go back to, I think, the fprintf function I got a little crazy with here. Excuse me. I think trying to pull this one off here didn't work out so well. Putting this with, it didn't work before either. So let's take a look at this, of doing that again. And let's take off this last element and take out this last thing here and see if this part works. So floor 1 on day 2 had a temperature, floor 2 on day 2, floor 3 on day 3, 1 on day 2, 3 on day 2. So floor 1 on day 2 at a temperature of 100. Floor 2 on day 2, that works. Floor 3 on day 3. Floor 3 on day 2, but there should have also been a floor 3 on day 1. No, this is days, these are floors. So okay, we'll go back to the beginning. Floor 1, which is the first column on day 2, here we go. And then floor 2, which is the second column on day 2. Okay, there we go. And then floor 3, which is the third column on day 3. See, and that one is a mistake right there. So something is wrong with the way we're doing this here. So day 3, floor 1. Yeah, and it doesn't have it right in there. So let's look at floor again. 1, 2, 2, 2, 3. Day. 3, 1, 2, 3. 2. Yeah, it's all mixed up here, and I don't know why. So to fix that, we'll have to go back to figuring out what we did wrong with fprintf, which can happen. So if we do fprintf, there we go. fprintf examples. Print literal text and array values. So here we have format spec. X is 4.2 F meters. So this one has 4 total characters, has the 9.90. 2 of them are decimals, that's correct. And then you print that off, the F. This one has 8 total, with 3 of them being decimals, that's correct. And then you put in A1 and A2. A1, the being 9.9. A2. A1, A2. I think I'm doing it right. Let's look back over here. I'm printing an array. I think I see what I did wrong here. D2 1, 2, going closer. Floor 1, 2, 2. Okay, yeah, I see what happened. I can see what happened. So what we got here is I'm looking to get floor 1 here, and then floor 2, and then floor 2, and then 2, and then 3, just like I've got it up here. But what I've got is I've got 1, 2, 2, 2, 3. So I put it in incorrectly in this array over here, and I think to fix that I need to, and so I did that with that. Let's do it with this one and see what it, and this gives the same result. So I think what I should do is I think what I need to do is change a little bit how I go about the beginning of this. And that is back here at the very beginning, when I looked at the different temperatures, that were greater than, right here, when I found the temperature greater than 96, I made this array of 1, 2, 3, 4, 5 numbers that were greater than 6, and then I made the days and the floors, but I never gave this thing a value. I never gave this thing a name, and I think I need to name this something. Let's copy that. Let's put it down here. Let's paste it. And let's give this a name. Let's call this, let's just call this A or something. A equals this. Okay. So A is equal to this now. And then I can do this previous fprintf, and I think I can print off now just the part of floor and day that I want. So let's check to see if that works. See matrix dimensions. Is that not right? No, not quite right there either. I need to get the same thing in the same spot. Let's try it this way. For day. There we go. So what I'm doing is I'm choosing the temperature element that I got in A here, these numbers that we pulled out, and then I'm going to use that number to set all these other ones. So on floor 1, on day 2, let's see, that's still putting them in the wrong order though. Yeah, we're getting closer though. We're getting closer. Oh, that's because I didn't finish this. At a temperature of, let's do this, nope, do it again. Temperature percent. So I'm going to put back in my my original thing here. There you go. So this one here, floor day temp, put an A here instead. So we're closer again, but we're still not quite there because I still have the numbers not in the right order. We're so close. I think I maybe know what we did wrong there. Here's really what the problem was, maybe. There it is, I finally did it. The problem was that when I made this array back here, I was getting these columns in my rows and my rows in my columns, and I didn't think that we should switch the rows and columns by inverting it or by transposing it rather. So I transposed this array over here of the floor, day, and the temperatures, and now I've got it on day 1. Floor 1 on day 3, temperature of 100. So floor 1, day 3, there we go. Floor 2, day 1. Floor 2, day 1. There we go, finally got it. But that's debugging for you. You can see what's wrong with the program at first, and you start looking for things that you may have to change. And finally I figured out that first of all, I needed to have an index, essentially. I needed to have something here that told me which part of the temperature array I wanted to pull out. And the part that I wanted to pull out had to do with this question where I'm finding all the temperatures that are greater than 98.6. And so I take out that number, that part of the array temperature, and I'm putting it in there. And then the floors and days I just take out one at a time. But I was getting rows and columns, columns and rows, so I switched it using the transpose operator. Remember the transpose if you have an array? If you don't remember this, if you have an array like A, for example, it's this column array. If I do A transpose with the little single quote, it turns it into a row. And so that's what fixed it in the end. So now you know, lots of fun stuff. So that is how we do selection stuff. You use the find. You can use the find function, and you can start to select things that are greater than, less than, equal to, not equal to, and then print them out using stuff from last week. The next thing we have to do in the next 45 minutes or so is begin to use the logic functions. We're going to start off with the if-else structure. And let's just make it pretty simple. I'm going to close all, clear the command window, close everything, clear. So that's good. Okay, so we're starting over again, fresh slate here, and we want to use the if function. So we're going to do help if, see what it gives us for that. So the if expression, it's a conditionally executes statements. So it's essentially asking, you're essentially using this as a question again, and you say if something is true, or something is not true, or if you satisfy these conditions, then you do something. And then you can also have an else if. So if you have this thing, you do this, but if you don't have that, then you can do something else. And that's what the else if is about. But then you also have else. So if, else, and then at the end of one of these statements, you always have to put an end, because this is like a little mini function within a function, or a function within your statements, whatever. So let's say if let's say x is equal to 5. Let's say if x greater than 6, y equals 5, or something like that. Right? And let's say, well, what is y equal to? Well, y doesn't have anything. Right? What if I say x equals 7? Put that in there, and then we'll do this function again. If, oops, I didn't finish it. So if x equals 6, y equals 5, and then I have to put an and in there. So I hit end. Let's do that again. If x, let's actually do a better one. If x is, let's say if x is greater than 5, which say if x is greater than 3. And notice that when I press enter here, it's not giving me a new generator here, because I've got all these if statements here. Let's end this, and let's end this. Let's end everything, and let's start over here. Let's clear the command window. Let's clear all of our things. Let's set x equal to whatever it's going to be equal to, 3. And then notice that if I put in an if statement here, I say if x is greater than 2, and I hit enter, it actually doesn't give me a new cursor to start with. There's no little arrows here. So it's waiting for me to put in an AND. So let's do, if x is greater than 2, x equals x plus 2. And then let's put in an AND and hit enter. And let's do this one. If x is greater than 2, let's do y. Let's do a different variable. Y equals cosine x. X cosine x divided by 10. Something like that. And then let's end it and see if it lets us do it. I did a wrong definition here, so I need to do it again. Y equals x times cosine x, not x cosine x, right? And then end here. So now it's actually defined my y up here. You can see in my workspace. It's calculated y because x was x was greater than 2. So I go ahead and put in the x, multiplied x times the cosine of x, and it calculated the number. And that's great. If my x is equal to 10, for example, here, and then I try to do the same thing. If x, let's say if x is less than 2, goodness. Try it again. If x is less than 2, there we go. Then I can go ahead and put in this, for example, copy that down there, paste it, and then end it. Then notice it hasn't changed y at all because it didn't execute the command because x is now greater than 2 instead of less than 2. So anyway, it's just a simple little function, but it can have lots of great uses. So let's do some more examples. Let's try this one. If g is, let's see here. Let's do it this way. Let's start off with g equal to 100. No, let's try 100. And then let's go ahead and say if g is less than 1,000, then we'll do display. We use the display function here in this case. We'll go ahead and display a string. G is small error and 1,000. Close that off. And then I can do another display, but I can do another display if g is not less than 1,000. So else, I could put in an else, for example. So this is if g is essentially greater than 1,000 or equal to 1,000. Else display g is greater than or equal to 1,000. Right? Then we have to end it. We go here. So g is smaller than 1,000 because it's 100. Right? So you can use it to just get answers back. You can use it to create your own answers. You can get whatever. You can use it. You can use the if then, or the if else statement to do quite a bit actually. You could also do. Let's do if x. Do I still have an x up there? I do have an x. So let's say if x is greater than 0, then we say y equals x times log x. And but if I want else, I say I can display something as well. I can do a calculation then a display. Base display, don't never take the log of a negative number, dummy. All right? Something like that. And then, of course, you remember you have to end it. So it takes the logarithm of x times x because x is greater than 0. But if x was less than 0, it would have displayed the thing that I told it to display and so on. So that's the if and the else function. We have the else if also. So here's another example. If, let's do, let's say we're going to say, find out if people are old enough to drive. So my son is 15 years old, so I'll let his age, A, equal 15. And say if A is less than 16, we can display sorry, dude. Too young to drive. Make sure we put those in quotes. Right? Well, it's not going to let me fix that line now. It's going to say ooh young to drive instead of too young to drive. But I can also put an else if in there, all one word, else if A is less than 18, right, there we go. Say, display. So what the else if is going to do is it's going to say, if your number is less than 16, it displays the sorry dude, too young to drive. But if it's greater than 16, then it's going to do this one as long as you're less than 18. So I can do a display, you get to drive with a youth license, youth card, we call it. And then I can also do an else for all the other cases, which is everything that's greater than 18, right? So I can do else display get on the road, right? End that out and be done. Sorry, dude, too young to drive. So you've got a lot more versatility once you start using these logical functions. You can start to have different situations where you do different things. And that is the whole idea, of course. You want your computers to be able to do that, to make decisions, and so on. And you can put as many of those else ifs in as you want. I mean, you can put in lots and lots of them. So if I copy this, I think I can paste this in here. Yep. I can put in one right here. Oops, I can't put in an extra one, I guess. And fix that one. Let's see, if I go paste this in here. I do else if here A is greater than, say it's greater than 65, you might want to display something like time to check your eyesight for people who might be losing their eyesight as they get older. And then I could end it. And you could put in lots and lots of else ifs, and then you could do another else at the end. You know, for else, for all other cases, in other words, is what this else means. For all other cases, keep on rolling. Right? But you always have to end at the end with an end, otherwise it won't know what to do. Okay? So, that is the if, else if. And you can use that in a lot of different ways. The last one that I'm going to review today is called the switch and case function. Also a very useful function. So let's go ahead and do this one. Let's do help switch. See what it says here. Okay, switch among several cases based on expression. So you start off with switch, and you have some expression, and then you have different cases or different situations. And essentially what you're going to do, excuse me, I have to sneeze again. It's been very dry up here in North Platte, so I think the dust is starting to blow around here. But anyway, you're going to have an expression that you start with, and you're going to, and the MATLAB is going to compare this expression and see which case it matches, and then it's going to go with whatever you have, whatever conditions you have in that case, whatever things you're supposed to do in that particular case, and then you can have an otherwise as well. So you can have different cases and then an otherwise statement. It's very similar to an if else if statement, but useful in little different ways. So let's go ahead and try some examples of this. Let's take a look at it. Actually, here's well, let's just do our own example. Okay, so let's try something like this. Let's try this. A city. We're gonna make a variable called city, and it's gonna depend on what the user inputs. So the city is gonna be based on an input, and let's actually put this in an M file. Let's do a script. City equals input what is the name of your hometown? Right? So that's the first thing that we're going to ask for, is the name of a city. And then we're going to have we're going to have some choices to choose from, essentially some cases. So I'm going to start off with my switch statement here. I'm going to give myself a little space here. Switch statement, and my switch statement is going to be based on this variable that I'm going to put in city. So in the switch case, the switch statement is going to look at the variable city that was put into the computer by the user, and it's going to compare it with different cases that I put in below here. Notice that it knows that switch has different cases, so it's already indented for us. And we'll call it case, and let's say, let's assume somebody might put in Lincoln. Somebody might put in Lincoln. So in the case somebody puts in Lincoln, I hit enter and notice that it indents it again. So now you're putting in what you're going to do if the city was Lincoln. Let's display Go Huskers. All right? And then now that that's all I'm going to do is just do Go Huskers. And so I actually want to do a new case. So I'm going to write case here again. And it's going to put me back to this indent. Because you can put switches within switches. And so it knows that if you put a new switch to indent again. But we're not going to do switches within switches. So it puts it back to this place. My next case is going to be, let's say, Kearney. Right? So my next case is Kearney, and I'm going to display Go Lopers, all right? And then I'm going to put another case. MATLAB does that for me. And then I'm going to go ahead and say what my next case is Provo. One of my kids was born in Provo. Most of my kids were born in Provo, Utah. Or nearby. And I'm going to display Go Cougars. And at the end of all my cases, you can put in an otherwise. So I'll go ahead and do that, otherwise. You don't have to. It's wise to make sure that you have all cases covered. So if they put in anything else besides Kearney, Provo, or Lincoln, then we'll just say, let's put in display Go Home, or something goofy, whatever you want to put in, right? Doesn't matter. At the end of this, I'm going to end it, and it'll put the end in the right place. And I can go ahead and save this. Call it Untitled 2. I don't care what it's called at the moment. And we'll just run it and see what happens. So it's what is the name of my hometown city? I put a question mark there instead of a space. Oh, city equals input. So I should have put a semicolon after that, so it doesn't say that. This city input, I'm going to put in, I'm actually going to change that really quick. I'll put in Provo and we'll see what happens really quick. The name of my hometown is Provo. It doesn't like that for some reason. Line 1, there's a problem with this. What is the problem? Well, let's fix this really quick. City equals input. Do Lincoln. Okay. So there's a little trick for you. For some reason I got stuck in a loop in this thing. I don't know why. I'm going to take this all out and put it into the command window and see if I can figure it out. But if you get stuck in a loop in your window where it just keeps doing the same thing over and over again or just stops doing anything, go ahead and push Control C or I think it's Control C on Windows as well, but it's Control C on Mac. So I'm just going to go ahead and do this and see what happens. Maybe it'll be better. It's not. If I enter it in, there we go. So I had to enter it in quotes. That was the problem. We wanted to know it in quotes, and so I should have used probably a different function so that it brings in that city as a string. Oh, I know how I can do that. And let's actually do that again. We go up here to input city as the name of your hometown, and then we tell it to input this as a, so we put this as a, so put comma. If you remember, the input function allows you to convert things that are typed in into strings, so we put that into a string like that. Then you don't have to enter the quotes, and you can just type in the city. So what is the name of your hometown? I put in Provo. It says Go Cougars. If I run it again, what is the name of your hometown? Lincoln. Go Huskers, right? And I can also suppress the input of the city, the output of the city, so it doesn't actually show it like that. Save that. Run. Hometown. Kearney. Lopers, right? So that is the switch and case statement, where it's going to switch, it's going to put things in a particular case, it's going to compare with everything and put it in the place that it fits, and then run the code that's underneath that particular case. So if I do this again, and I say that I was born in Ogallala, right, it says go home, because Ogallala doesn't fit any of these things. And that's fine, because people from Ogallala probably like going home. Anyway, that's the idea. Okay, so switch case studies, or switch case, the switch case structures, very useful. The last thing that we're going to talk about is something that's used often with the switch case, which is the menu. And so here's an example. We'll let input equal menu. And in menu, we're going to say select a city. So you're just typing in select a city. And then I'm going to put I'm going to close that out, and then I'm going to put a comma, and you can choose Kearney. I'm going to put that in the single quotes, and then comma, single quotes Provo, single quotes, comma, and single quotes Lincoln. Right. So there's my command. And what it does is it brings up a little menu window. So this is your first foray into what we call GUI, or graphical user interface. MATLAB has built into it this ability to make this graphical user interface very easily. So now we can just click on which one of these cities and it puts it in the input. So at input number 1, if I run that again and I click Provo, it takes number 2. So it tells you which one it's selected from that list. It shows the first one, or the second one, or the third one. And if I suppress the input, it still saves it. It just doesn't show you which number you chose. Except if you go over here and look at in your workspace, it shows the input number 3. And then you can add some code to that. So let's do here. Let that equal that, and then let's actually do this. Let's city equal menu. What is the name of your hometown? And instead of this here, let's do comma Kearney in quotes, comma Lincoln in quotes, and comma Provo in quotes. So now I've got a new thing that's our city. Then we use with our switch case, we can use city, case Lincoln. And instead of case Lincoln, because it's not going to give us Lincoln, it's going to give us a number. So we say case 2, right? The case, actually, city equals 2. So in the case that city is equal to 2, actually, we just call it case 2. And then Kearney is 1, so we'll call it case 1. Kearney is the first one on the list. And then case 2, well, let's see, this one is actually 3. So 3, 1, and 2 for the different ones here. And then we're going to go otherwise, go home, we can hit end, we can save that, and we can run it. Apparently we can't run it. Why can't we run it? It's because we have this. So let's run this again. I used capital M in menu. It's actually a little m. So then I choose Kearney, and it says, whatever it says, go Lopers. Provo, okay. So now I'm going to save here, and then run here again, and I'm going to press Lincoln. It's going to say, go Cougars. Apparently I got it wrong. What is my... So Provo is actually the third one. So this is case 2. I got them backwards. Case 3 is go Cougars. Save that, run that. So now I go ahead and I press Lincoln. It says go Huskers. So anyway, that's the menu. Gives this your first foray into the use of little point and click, the use of windows, little pop-up windows. And that is all I've got for you today. So unless you have any questions, we can be done. Do you have any questions for us today? Not hearing any questions, so we will go ahead and call it good. We'll see you later.